For this session, we will continue with the TOVA program's highway assignment section and provide a lecture on various functions and path analysis within the highway section. First, please close the test network created in the previous session and open your project. Navigate to the Gangnam 2018 folder in the sample directory and select the Gangnam 2018.tpx file. First, I will explain the functions in the table menu, specifically column addition, column calculations, and statistics functions. When you activate the link table, not only the link table, but also the node, zone, and turn constraint tables will be activated, and you will see the menu functions at the bottom. Here, I will begin by explaining the column addition feature. When you click on Add Column, a subwindow appears as shown. Add Column is divided into two categories: data column and code column. The code column section is not commonly used in general. So for this session, I will focus on explaining data columns. When selecting a data column, you are required to first enter the column name. After specifying the column name as a VP, you have the option to choose the data type. As you can see, there are three options: double, integer, and string. Double is chosen when you want to store data with decimal points. Integer is used for storing data with only integer values. And string is selected when you want to store data in text format. Since we are going to input validation points, we will set it to string. Information is the data content section, which allows you to enter a description for the respective column. It's not a mandatory requirement. Once this is completed, by pressing OK, the VP column will be added to the data table below as shown. Next is the column calculation feature. When you click on the Calculate field menu, you first choose the output column where the calculated result will be stored. Then, in the calculation space below, you input the actual calculation formula. The application conditions below determine under what conditions the calculation will be made and stored based on the formula you entered. For instance, you can apply it when you want to input the alpha and beta values of the VD function from the linked table by if_in_id. You can input 0.15 in the alpha column. And when if_in_id equals 35, then click the OK button. By the way, the link data for the network you are currently working on has already been entered using this method, specifying alpha and beta values as well as capacity and speed by if_in_id in advance. The column operation function will be frequently used when you need to perform tasks such as network validation. where you compare model-assigned traffic volume with observed traffic volume in the network. Next is the statistics function. As you can see, it is divided into two parts, foundation stat and goodness of fit. Let's start by explaining the goodness of fit function. This function is not frequently used, as it involves comparing values entered in different columns with each other. The foundation stat section is a feature that allows you to perform basic statistical analysis on the attribute values of each independent column. As shown on the screen, you can select the columns for which you want to perform basic statistical analysis, such as capacity and speed, and then click OK. This will display the sum, average, minimum, maximum, and other basic statistics, as seen in the example. Additionally, by choosing Group field, you can check statistical values based on different types or groups. Errors in entering incorrect values often occur when editing links or attribute values. These errors can disrupt the smooth operation of highway assignment, so foundation statistical analysis is frequently used to identify the causes. The most common errors typically involve entering alpha values as 0 or beta values as less than 1 during the process of modifying links. These types of errors can be identified and corrected by using foundation statistical analysis to check what the minimum values have been entered as. Furthermore, foundation statistical analysis is also a valuable tool for identifying cases where capacity and travel speed are excessively high, which is the opposite concept. The next part is about setting model parameter. When you click on parameter in the main menu at the top, various menus will appear. Among these menus, if you click on the Highway Assignment section, which is the main focus of this session, you'll see that a sub-window becomes active as shown. Model parameter settings are repetitive tasks. For example, occupancy by modes and passenger car equivalent in highway assignment are always input each time you perform highway assignment. However, to reduce the time-consuming nature of this and minimize input errors, this feature is used. In this project, you can understand it as meaning that we will always apply the values entered in the model parameter settings when performing highway assignment. Now let's go through the contents of the sub-window one by one. In the upper left corner, you'll find the value of time for toll road, which can be understood as the value of time used to convert toll charges typically paid when using toll roads like highways into time. In the current network's case, there are highways, but only 3 sections exist, so this value can be set to 1. If this were a road network in Tanzania, you would input the values obtained through the time value and toll fee surveys here. Next is the part about odd matrix time duration parameter, for the daily capacity conversion. This section requires a careful checkup of the data and network structure for application. When you look at the numbers in the capacity column, you can see that they are in the range of a few thousand units, representing the hourly capacity. For the mode OD, daily OD is entered. Therefore, the daily capacity conversion parameter should be applied, and the default value of 10.0 should be used. If the data is structured with hourly capacity and hourly OD, applying a value of 1.0 is more appropriate. Next is the part about entering average occupancy and passenger car equivalent. As I mentioned during the previous session on entering mode OD data, the OD data we've input is currently in trip-based traffic volume. To put it simply, when one person travels from location A to location B, it's understood in terms of trip units. However, in highway assignment, the basic unit of assignment is done in PCO, passenger car unit, so a process is needed to adjust the units. By the way, as for the capacity part of the link data I mentioned earlier, it's already known to some people that it's in PCO. For example, when traveling by car from location A to location B, that car may have one person in it, 3 people, or even more. Therefore, the process we need to perform is to convert the trip-based passenger car traffic volume that's currently entered into the data into vehicle units by dividing it by the average occupancy in a passenger car. By the way, as for the capacity part of the link data I mentioned earlier, it's already known to some people that it's in PCO. For example, when traveling by car from location A to location B, that car may have one person in it, 3 people, or even more. Therefore, the process we need to perform is to convert the trip-based passenger car traffic volume that's currently entered into the data into vehicle units by dividing it by the average occupancy in a passenger car. Next is the passenger car equivalent. When considering the space occupancy and acceleration-deceleration capability of vehicles on the road, it's not the same to equate the presence of a bus or a car traveling on the road. Therefore, the PCE is the value that represents how many passenger cars equivalent to other types of vehicles, such as bus or truck, impact the road. For vehicles other than passenger cars, like bus and trucks, you need to multiply the passenger car equivalent to account for their influence. This is done to convert both road capacity and traffic volume into PCU units for purposes like V/C analysis, travel time analysis, and other road assessments. In this way, by dividing trip-based traffic volume by the average occupancy and then multiplying it by the passenger car equivalent, you can calculate the traffic volume in PCU. The average occupancy and passenger car equivalent values you are looking at are based on Korean guidelines. If you were to apply this program to a road project in Tanzania, it is recommended to use the values obtained through roadside surveys for average occupancy for the passenger car equivalent. You can apply the standards outlined in the Tanzania Road Geometric Design Manual if available, or if there are no specific standards, you may consider using values from the US HCM. With the input of average occupancy and passenger car equivalent in this project, users can perform highway assignment in PSU units within TOVA without the need for separate calculations. Lastly, on the right, you'll find the volume delay function section, which includes options for applying a single VIF volume delay function, applying by event ID, or applying by link. The choice of method to use can be determined during the operation of the highway assignment model. It's worth noting that these cells are associated with the columns in the link data. With these settings completed, you can proceed with the highway assignment model. Click the OK button. Now let's go ahead and run the highway assignment. To do this, click on the highway assignment model in the main menu models at the top. A warning message has appeared. The reason is that the model was run without performing a network check. If you click OK, the network data inspection window will appear. Please check 101 and 102 as expressway in the highway network data and check 108 as a ramp. Afterward, click on Run. If you have confirmed 0 errors in the network inspection result, click Close. Now you can see the Highway Assignment Models window. In this sub-window, you will first find the section in the middle where you select the highway assignment model you want to use. TOVA defaults to the equilibrium assignment method, and it recommends the use of the origin-based assignment. After selecting the highway assignment model, the next step is to click on Trip Matrix, which can be understood as the process of selecting the data for which mode to assign. The values you see on the screen for OD matrix time duration, average occupancy, and passenger car equivalent are confirmed to be the ones you set in the previous model parameter settings. If you don't set these parameters in advance in the model parameter settings, you would need to input these values every time after selecting the mode. The reason for introducing the model parameter settings first is to eliminate this inconvenience. Returning to the main topic, since we are going to perform highway assignment using all modes, you should select all modes in the list. On the right, preload refers to a method of assign the mode to the shortest path between origin and destination before performing equilibrium assignment. We won't be using this method in the current project. After checking the modes in this way, you can click OK, and the next window for setting the volume delay function will become active. You should now click on Volume Delay function, and you will see a screen similar to what you observed during the model parameter settings. This step involves choosing one of the 3 methods for setting the volume delay function. Since our network has individual alpha and beta values for each link, as shown below, we will select individual link-specific VDF for assignment. As a reference, All link means applying the same alpha and beta values to all links, while each function is a method where alpha and beta values are applied based on fn ID and function number as shown below. With the completion of the volume delay function settings, the next step is to click on Run Options. Execution option settings determine the conditions that will be checked either during or after the highway assignment phase. In our current network, we don't have turn restriction data, and we don't have bus initial volume either. Therefore, as shown on the screen, these options are disabled. Because there is no data currently available, the application of intersection delay analysis is still in the process of being developed. Therefore, the parts we can currently check are the post-highway assignment analysis options for turn volume analysis and path analysis. The warm start feature allows you to utilize the results of traffic assignment from a previous scenario when performing traffic assignment. It has the advantage of reducing execution time by using the previously performed traffic assignment results. However, for small networks that run in the free mode, the time required for traffic assignment is very short, so we won't be using this feature at the moment. Finally, path volume balancing process section. This part is about adjusting the model-specific traffic ratio between origin and destination points after user equilibrium assignment. Currently, we will leave this section with the default value of 0. The next step is to input the stopping criteria for iterative execution. This part is about setting the termination conditions for traffic assignment. On the left, the disabled friction factor menu is only available when selecting the incremental assignment method in the middle of model. Click on Stopping Criteria. The termination conditions are set based on the number of iterations and the relative gap. Generally, it is recommended to use the relative gap instead of the number of iterations. You can select the default value of 12 or 10. This means that the iterations will terminate when they converge to a value close to 10 to the power of negative 10. If either of these conditions is met, the iterative process will be ended. In the scale factor section, the zone centroid through refers to whether the assigned traffic is allowed to pass through the zone center. It is generally recommended to set this to no to prevent traffic from passing through the zone center. The scale factor can affect the convergence speed depending on the value you input. In your current network, it's mentioned that this parameter doesn't have a significant impact, so you can leave it at the default value of 0.5. After completing all the configuration settings, the final step is the output settings. Click on it. Currently, since there are no previously performed traffic assignment results, only new is activated. A brief overview of the contents. Additional output items that are stored in the linked table include average travel time, V by C, total volume, and model-specific volumes. Once a traffic assignment has been performed, the overwrite option is activated. After confirming this, you can click Run. Then Highway Assignment Model will be executed. Once the traffic assignment is complete, a message stating assignment complete will be displayed at the bottom. You can click the Close button to exit. Now you can click and see the log file. Click on View Log. Often, when performing traffic assignments, there are cases where you need to perform consistent assignments under the same conditions, but you are unable to do so. In such situations, you can use the log file to check what has been input differently. While viewing the log file, you can get a brief explanation of the conditions and network information under which the model was executed. Please proceed to view the log file for further information. First, let's look at the Input Parameters section. This section displays how the average occupancy and passenger car equivalent were applied for each mode and whether preallocation was applied. The Run Options section shows whether turn restriction, turn volume analysis, scheduled bus preloading, path volume analysis, warm start, and balancing processes were applied, along with the input values for processing control parameters. In the Network Information section, you can confirm the quantities of zones, nodes, links, turns, and more within the network. In the Travel Demand Information section, you can see the number of modes applied for demand estimation and the PCO travel volume. These are indexed for each iteration. Here, you can see that the relative gap is gradually decreasing, and the iteration process stopped on the 35th iteration. Reaching a value lower than 10 to the power of minus 11, which was set as the maximum relative gap for termination. These sections represent the final values after the iteration process has concluded. VHT, it stands for Vehicle Hours Traveled, representing the sum of the product of link assignment volumes and link travel times. VKT, it stands for Vehicle Kilometers Traveled, representing the sum of the product of link assignment volumes and link lengths. In these results, Zone Connector represents values specifically aggregated for Zone Connector travel data, Toll for toll road travel data, and Network for travel data on other road segments. Hence, total VIT represents the sum of values for Zone Connectors, toll roads, and network segments. The title of the output file, which is User Equilibrium Origin Based 1, and the total processing time it took to complete this task, which was 1.859 seconds. Now click the Close button in the upper right corner and also close the model window. Let's take a look at the link data table. Now look at the link table. You will see that new columns have been created to the right of the fifth column, and you can see the traffic assignment results values in them. In the link table, you'll find the following columns stored: average time plus V by C ratio, total volume, and the volume for 7 different vehicle types. Average time represents the pure travel time for the link and is measured in minutes. Average time plus includes the added value of toll road waiting. For links without toll road waiting, the values in the average time and average time plus columns are stored as the same. Next, V by C represents the ratio of traffic volume to capacity for each link. By clicking on the column headers, you can sort the data. For example, if the VC for link age 72,626 is high, it indicates a congested segment. To locate the position of this link, you can right-click, select Zoom to, and see the corresponding location on the map. Total volume represents the sum of all modes of traffic volume and is measured in PSU. You can also check the traffic volume for each mode in the other columns, and they are also measured in PSU. I've provided an overview of the highway traffic assignment model execution up to this point. In the next session, I will continue with explanations related to path analysis and thematic mapping. Please save the demonstration we have performed so far. You can do this by going to the main menu, selecting Project, and then clicking on Save.